An electron is accelerated to a potential difference of 350 volts. Find the frequency and the wavelength. So how we will do this question? Let's take it here. So the electron, it is question number 4. The electron is accelerated by how? By the potential difference of 350 volts. Right? Now your work done is equal to what? It is the increase in kinetic energy. Right? And how this energy will be increased? By the potential difference. So there is potential difference into the charge. Now that will be equal to, what is the potential difference? It is 350 volts multiplied by the charge, that is what? 1.6 into 10 to the power minus 19 joules. Right? So, what do you want to calculate here? What was our question? We want the frequency as well as the wavelength of the electron. So, if we have got the kinetic energy, that is your kinetic energy here will be equal to 350 multiplied by 1.6, and it would be 560 into 10 to the power minus 19 joule. Got my point? So it is 350 volts multiplied by 1.6, and it would be 560 into 10 to the power minus 19. Now how can we calculate the wavelength of electron? Wavelength is equal to h divided by square root of 2 into mass into kinetic energy. So it would be lambda is equal to h is 6.626 into 10 to the power minus 34 divided by square root of 2 into 9.1 into 10 to the power minus 31 into 560 into 10 to the power minus 19. So what will be the wavelength here? Lambda will be equal to, so let's first solve the below one, that is the root. So we have to do 2 into 9.1 into 10 to the power 31 minus, and that is equal to this, multiplied by 560 multiplied by 10 to the power 19 minus, that is equal to 1.01, and if I take out its root, it would be, the root part is, we have solved, and it comes out to be, this answer would be, the root part we have solved, and it is 1.00 into 10 to the power minus 22. So your lambda, the wavelength will be equal to 6.626 into 10 to the power 34 minus divided by 10 to the power 22 minus, and that is equal to, that is equal to 6.6 into 10 to the power minus 12. Right? This is your wavelength. So, now what you need to find out is the frequency. of the wave. Can you find out the frequency of the wave? What is the expression for frequency? Can we find out by lambda is equal to c by mu? Or how can we take the frequency? You can find out the frequency by frequency is equal to c by lambda, right? Or the velocity by lambda. So for that, first what you need to find out, there is velocity by lambda. So we have got velocity over here. We need to find out the velocity. How will we find out? It is half of mv square is equal to the kinetic energy, right? Now what is your kinetic energy? Half into the mass of electron, 9.1 into 10 to the power minus 31, multiplied by v square, and kinetic energy is 560 into 10 to the power minus 19. So your v square will be equal to, that is 560 into 10 to the power 19 minus multiplied by 2, that is equal to 1.12 divided by 9.1. So if you'll divide the whole thing, you'll solve the equation, you'll get 1.2 into 10 to the power 14. Then your velocity will be equal to the root of this, and that is 1.1 or 11.1 into 10 to the power 6 meter per second. Now you need to find out the frequency, and the frequency will be equal to the velocity which you have calculated, 11.1 into 10 to the power 6 divided by the wavelength, that is 6.6 into 10 to the power 11 meters, right? This would be 11. So and that would be what? 11.1 divided by 6.6, and you will get 1.68. This is 11.1 multiplied by 10 exponential 6, that is divided by 6.6 into 10 to the power 11, and you'll get 1.68 into 10 to the power minus 5 per second. So this is your what? This is your frequency. This we have got our frequency, but I made a mistake here. It should be minus 11 only, and here it should be what? 6.6 into 10 to the power minus 11, and then we will calculate the frequency. So what is the frequency we will get according to this? 11.1 into 10 to the power 6 divided by 6.6, that is equal to, and here our answer would be 10 to the power 17 per second, right? So it would be 10 to the power 17 per second. This would be the frequency. Okay, so this was the solution of our question.